Okay, so welcome back, and we are going to formally start our journey on the subject of kinematics. And this is where you probably will not realize it as you, or it does not feel like it as we go on. But believe it or not, this is probably the most important topic in physics. It's the central idea. It really encapsulates what physics is about. It really is the essence of physics. What do I mean by that? Well, this is, like I said, it's the study of motion. Okay, so let's understand the words first, right? Kin means to move. It's the old sort of Greek origin word of motion, or to move. And matics is the study of. So it's the study of motion. Okay, so why is this important? Well, essentially, what we are allowed to, this subject will allow us to do is, it will basically allow us to predict the future. What do I mean? Is if you know everything there is to know about the initial state, about the current state of what the situation is, you will be able to unambiguously and accurately and precisely predict what happens in the future. All right. So imagine how powerful this is. So just to give you an example, if you set up, let's say, a slingshot or a cannonball, right, and you know exactly how much force you put in here, you can predict exactly where it lands, at what velocity it lands, and how far away it lands, and everything you need to know about the future of that ball or the path that it traversed. So everything from shooting a cannonball, to shooting an arrow, to kicking a football, to sending rockets into space. If you want to send recently a satellite or a rover to Mars, or to any other planets in the future, this is all actually the theory of kinematics, and this is the foundation of everything. Now, why that obviously is very powerful, but I think I motivated in the first lecture that it is even more powerful than that. Even things that you don't think is to do with motion. For example, the theory of electricity, or the theory of heat, or the theory of I don't know, water, or how water transforms into steam, and solid, liquid, and gas, and states of matter. These things you will think of, oh, that's physics, right? But that's not necessary to do with motion, but it is, because the electricity is basically just the flow of electrons, or the flow of currents, right? And you will learn about that in 3B. And water or heat is basically the motion of atoms. Atoms would jiggle around, and the more they jiggle, the more the temperature, the higher the temperature it is, and that is essentially heat. So when you touch something that's really hot, basically the atoms and molecules are jiggling faster than something that is not. And if you are able to cool it all the way down to absolute zero, that's when the atoms basically stop motion. And that's why there's a minimum of temperature, and you cannot go below absolute zero, because what does it mean by moving less than not moving? You cannot do that. So when every single atom in something, then that's why it's also so hard to achieve. And it's actually impossible to achieve precisely absolute zero. But I'm getting ahead of myself. That's all in 3B. But yeah, that's why it's so hard to achieve absolute zero, to go down, because you need every single thing to stop moving, every single atom, every single electron to freeze in motion, and freeze, pun intended over there. So everything really is to do with motion, and this is the theory. This is the starting point of everything. So you will remember the day you start to learn this important topic. Okay, so how do we begin in such a vast and almost daunting subject? Well, there's two central questions we'll address. We'll focus our study into that. The first one is, well, this seems so complicated. This is such a complicated issue. How do we even tackle it? Well, we must need to be able to define certain things that we can measure. And that's what we call quantities, right? And if I want to describe the motion, let's say I want to describe the path of a tennis ball, or just toss a tennis ball from here to there. How many variables, how many quantities, or how many variables do I need? That's the first question, because if I need to measure and find out, let's say 135 different things about the ball before I can analyze its motion. There's no hope to enable to be able to do that. Well, turns out the answer is it's very simple. Turns out there's only 4 or 5, depending on how you count it. There's only 4 or 5 different things you need to measure. That's it, right? There's only, in fact, depending on how you count it, maybe 3 as well. So from a number that you can count on one hand, right? You can measure the number of things you need to know, and you can predict precisely what will happen in the future. Okay, so that's the first question we'll ask. What are the relevant variables or quantities there are? Okay. What's the difference between variable and quantity? Not much, really. It depends on what you're emphasizing. Variable is sort of a more mathematics word. Quantity is a more physics word. Quantity means something that can be measured. Can be measured, or a measurement of interest, right? What you're interested in measuring. So it's the things that you can actually measure. So force is a quantity. Almost everything you hear, most of the physics jargon. Force, position, velocity, acceleration, we'll go through all those, but those are quantities. Variables is somewhat more general. It's more of a mathematics term. It's anything you can give a symbol with. I'm not going to put a proper definition, but anything that appears in an equation, like, even mass. So almost we kind of will use these words interchangeably in math and physics, or especially in physics. But yeah, it's just, this has more of a mathematic slant to it. This has more of a physics flavor to it. Okay, so the answer to that, as I have alluded, turns out there's only 4 to 5, and you will know everything there is to know about motion. I mean, you can predict the future of things if you know the initial state of it. There's only, that's it, right? So the next question is, how are they related to each other? Okay, right? So if you don't know how they're related, you just measure 1 or 2 things. You won't be able to find out the third thing, right? So that is really important. In fact, that is sort of the bulk of it. But this is also important because we need to first be able to define our words. We need to understand what we're talking about before we start, right? Okay, so that let's look at the main kinematics variables or quantities, right? I like to call it the key players of our topic. Okay, and there's 3 main key players. Okay, and I'll just say it first: position, velocity, and acceleration. Okay, and then there's a couple of sort of spin-off words that has a slightly different meaning, but it's similar, and I'll explain what I mean. Okay, so mainly the main players are position, velocity, and acceleration. Okay, right, so these are the main players. However, you'll hear us sometimes talk about some, I'll call them spin-offs words, right? And they are displacements and distance. Okay, so in the next video, we'll talk about what is the difference between displacement and distance. And also, annoyingly, the total distance traveled can sometimes be different. Okay, so these 3 sort of spin-offs can sometimes all be a little bit different. Okay, and velocity, other than velocity, you'll hear us talk about speed. So in another video, we'll talk about what's the difference between velocity and speed. So we'll need to clarify that. And we'll also have the concept of average velocity, average versus instantaneous. Instantaneous. Okay, so I can have average velocity or average speed. I can have instantaneous velocity and instantaneous speed. So what's the difference between instantaneous and average? Okay, so we'll also clarify that. And last but not least, we'll also talk about what's the difference between acceleration and deceleration. Okay, and out of all this, there's also one more very important quantity or parameter, or variable, and it's called time, right? Because you want to know sort of how long it takes for something to happen. And this is kind of special, okay? It's special. I'll use a different color. And there's a special name for it. It's called parameter, okay? So a parameter, what is a parameter? A parameter is a special variable. It's also it's a math term. We'll use it. It's a variable. So parameter is a special type of variable, but it plays a special role. It's the variable that governs everything else. Okay. A parameter is a special variable that governs all other variables. Okay. What do I mean? Well, you've heard of in math, you know there's functions, right? So what this means, if there's a function, I don't know, 3x plus 5, right? So x is the variable that governs the output of f. So if x changes, f will change like that, right? So x is a parameter, and f is the output. Almost like an input, yeah, in terms of a function, but it's more fancy word. That's it. So what does that mean in physics is if I have a position, let's call it r of t, and we'll find that these are the things we'll be interested in. And basically, if you want to describe motion, you want to find out the position of everything as a function of time, the velocity as a function of time, and acceleration as a function of time. And you see that as time ticks on, it will change the position, it will change the object's velocity, and it may or may not change its acceleration. But time is basically the universal ticking clock. Well, it's a circular definition, circular reasoning, but you get what I mean. It's the variable that changes everything. Sure, this will change this. I mean, they're all related, but this is kind of how we present it, and time sort of plays a special role in this picture. Okay, all right. So our next task is really to clarify, or we'll split this into 3 parts, right? We'll look at what's the difference between these couple of words, what is the difference between these couple of words, what's the difference between these couple of words.